What's going on, guys? Welcome back to this video. As you can see, today's video will be on TryHackMe. And after we have finished the intro to cybersecurity track, we're going to go over the pre-security. So basically, I have gone through the various sections of this track and I have discovered that surprisingly we have covered all of these videos in the past. Well, except this. So intro to cybersecurity, network fundamentals, how the web works. I have covered all of these in the past videos, but maybe I haven't categorized them and declared them as being part of this path. So what I'm going to do to assist you, I'm going to add all of these videos in a separate playlist under pre-security, so you'll be able to access the playlist on demand. Alright, so today's video will be on Linux fundamentals, and although I have published a video 2 years ago on Linux fundamentals, it was full course on Linux fundamentals. I'm going again to cover what the same fundamentals laid down, but in TryHackMe. So we're going today to tackle all the 3 rooms together. Hopefully this will be an inclusive video, guys. You can get back to whenever you need something about Linux fundamentals. So let's get started with the first room, Linux fundamentals part 1. This is how we're going to do this. We're not going to spend time reading through the material because everyone can read. You're here to watch briefly and without any extension. So basically we're going to tackle the questions, and while we answer the questions, I'm going to explain how we got the answer and what's the concept behind each answer. Alright, so task 1 and 2, they are introduction. Task 3 is connecting to the machine. Now task 4 is running your first few commands. So if you are new to Linux, here in this task we have some basic commands to learn. Alright, so let's jump to the virtual machine that we're given as a lab material and find the answers for the questions. So this is the virtual machine we're given, and as you can see, we are logged into the Linux instance. The first question is, if you wanted to output the text TryHackMe, what would our command be? So basically here it's asking what's the command that you would use if you want to send something to the foreground of the terminal. So it is echo TryHackMe. Why? Because if you type whatever you type with echo here, it's gonna get sent to the output. Echo 1, as you can see, we have 1 here. You can also type echo as suggested TryHackMe. Now the usage of echo is much more complicated than this case in real world. So basically, if you watched my previous videos, we use echo most of the time during CTFs or during pen testing. If you want to, for example, update the contents of a specific file. For example, we can use echo to, as I said earlier, to update the contents of a specific file. So touch file 1, right? Echo TryHackMe. Okay, and then we send this. We're gonna talk about the arrow keys to file 1. Cat file 1. As you can see now, file 1 stores TryHackMe. So the usage of echo is much more than only sending a couple of strings to the output of the screen. But that's where we start. Now, later down the road, when we learn about the key arrows, when we learn about the pipes, we're gonna be able to use echo for the complicated scenarios we talked about. What's the username of who you are logged in as on your deployed Linux machine? So here, if you again watch the past videos, if you want to extract or if you want to see the identity of the current user you are logged in, say you have landed a shell or you have compromised a machine through a web server, you got a shell, you want to know what's the current user you have. So ID, as you can see, we see the UID of the user, we see the group ID and the groups it belongs to. Also, if you type OMI, you can see the name, the username, or you also can type host name. This is the host name of the machine. So that's the syntax. As you can see, when you log in, you have the username at the host name of the machine. So what's the username of you are logged in is TryHackMe. Okay, interacting with the file system. No worries about the readings. We're gonna cover these while we solve the questions. On the Linux machine that you deploy, how many folders are there? Alright, so the first thing, before identifying the folders, let's first find what is the current working directory we are at. We can find that by using pwd, print working directory. We are under TryHackMe. If we use ls to list the current contents of that directory, meaning TryHackMe, we can use ls, and as you can see here, we have the contents of the directory. The question is saying how many folders. So folders or directories, it doesn't matter. As you can see, the folders are highlighted with different color. And also you can differentiate between directories or files. If you use ls-la, you will see here, yeah, we can see some weird files. I'm going to explain them. You see here the directories or folders have the word D written before the permissions. It means that this is a directory, while on the other hand, files don't have it. As you can see, only permissions. That's how you make a difference between them. So we have 4 folders. Which directory contains a file? Alright, so here you have to find out which directory among these folders have a file. So basically, how you're gonna find this, we're gonna need to go through every single one of them. How do you do that? Basically, first we navigate to the directory we want to discover. So using cd and the name of the directory, folder 4. And now we want to see what are the current contents of the directory. We can use ls, and we have a note. Now we want to find or display the contents of this file. We can use cat and the file name, and as you can see, we print, or we can see the contents of this file printed out in the output. So how do you know it's folder 4? It's not by coincidence. I just went through every single one of them. Now if you want to go through folder 3, for example, you have 2 options. You can use cd and 2 points to go back 1 step in the directory structure. So right now we are here, pwd, we are /home/tryhackme/folder 4. If I want to go back 1 step, meaning I want to step back to TryHackMe, or my position will be at TryHackMe /home/tryhackme, I can use cd 2 points, and now I'm back 1 step. I can now cd folder 4 or 3 ls. As you can see, it doesn't have contents. Use the cd command to navigate to this file and find out the new current working directory. We already covered this here. Alright. Searching for files. Alright. Let's search for files. Use a grep on access log to find the flag that has a prefix of thm. What's the flag? So this is an example of using the grep command. Grep is used to grab a specific text or specific string that could be stored in a file. For example, let's go back. As you can see here, we have a file called access log. Now access logs are log files to store all the transactions that happen on your web server. Sometimes these files get messy, right? It has a lot of content. So you cannot just go through the file. It's going to be overwhelming if you just use cat, because the screen will be full. It's going to be full. Sorry, it's going to be full with the contents of this file. So we can strategically think of a more smart way of getting what we want. So basically, we want to go through the access log. We are actually in need of specific aspect, a specific metric or a specific variable from the access log. So what the access log stores? It stores the transactions that happen on the web server. It stores the IP address making request, the request type, the URL, the file. So if you can search, if you are after the IP address or after a specific file, we can use the grep command, right? So here we want to find the flag. So the flag, we all know that the flag starts with THM. So why don't we search, or why don't we grab every string that starts with THM? How to do that? So cat access log, and then I use pipe. The pipe here will send the output of this command. Look, we have double cats here. It will send the output of this command, meaning it will send the contents of the access log and feed it as an input to the command that will come after the pipe. The command that will come after the pipe is grep. And here I'm looking for a specific pattern, THM. As you can see, I got one line. Now this line has the pattern I was looking for, THM. And this is the flag that you will use to answer the question. And I still haven't found what I'm looking for. Okay, fine. Intro to shell operators. Now here they talk about the shell operators. This is a table, as you can see. And here's the difference between a single arrow and double arrows. We're going to talk about this. Ampersand, double ampersand. Alright. If you wanted to run a command in the background, what operator would we want to use? It's the ampersand. What do you mean by that? For example, if you have a script that is taking time to finish, if you're running a script and it's taking time to finish, or you know that the script takes time to finish, what you can do, you can run the script, for example, backup with sh, and instead of hanging in there and waiting for the script to finishes, what you can do, you can use the ampersand. What's going to happen when you run the script and append an ampersand to the very end? What's going to happen? The script will run in the background and you can continue working on your terminal while the script is running, instead of waiting for the script and hanging everything, right? That's why we use the ampersand. Another method is to use the Control Z. So you can execute the script again, and then you can press Control Z to send it to the background. Sending a process to the background is useful if you want to continue working on the terminal and you don't want anything, or you don't want the output of the command that you want to run to overwhelm the terminal, right? So you want to continue working on other aspects, on other tasks while the command is running or while the script is running. You can use the ampersand at the end of the command, or you can use Control Z to send this to the background. If I wanted to replace the contents of a file named passwords with the word password 123, what would my command would be? Alright, so we first mentioned that echo can be used to update the contents of files. Now here I don't want to update, I want to replace. Here comes the difference between single arrow and double arrows. So when we use single arrows, we're actually replacing all the contents in the passwords file with password 123. Take an example. Echo TryHackMe and send this to a file named, let's work with the current file. So ls cat file1. So okay, this file has TryHackMe. If I execute echo, and here as you can see TryHackMe, okay, passwords, so passwords, and send this to file1. Now cat file1, what happened? As you can see, file1 got only appended to the word passwords got only appended after TryHackMe. It hasn't replaced the word or the string TryHackMe. Why? Because I used double arrows. Alright, what if I use single arrow now? So remove this and use single arrow. For example, use updated passwords. Updated passwords. Cat file1. As you can see now, the old contents have been erased and updated with the new contents, updated passwords. Now this is the gist between, or that's actually the gist if you want to talk about the difference between these double arrows and a single arrows. Same here. Okay, conclusions and summaries, and now we finished Linux Fundamentals Part 1. Let's now jump to Part 2 terminate the machine, saving up resources. And now we move to Linux Fundamentals Part 2. Intro, accessing your Linux machine using SSH. Let's first deploy the machine because it's going to be a separate machine. This time we're going to access the machine using SSH. So here I have the attack box running, I guess. Reconnect. I have to respawn the attack box. Okay. So here we have the credentials. Make sure that you use the credentials that will pop up here. SSH TryHackMe at the machine IP that is getting spawned now. And the password is TryHackMe. We're gonna log into the machine from the attack box. As you can see, it's telling you that to start attack box from this. Intro to flags and switches. Alright, let's give this a couple seconds. Okay. Split. Hopefully the attack box is working now. Good. Clear all of this shit. And now we scroll down. What? Does it work? SSH, it's not hard, man. Come on. So here, looks like the machine hasn't started the SSH service yet. So, flags and switches. Explore the manual page of the ls command. What directional arrow key would we use to navigate down the manual page? Come on, it's down. The down arrow. What flag would we use to display the output in a human readable way? We're going to talk about this. So obviously it doesn't want to start. So what I'm going to do, I'm going to power off the attack box because simply doesn't work, and respawn the attack box one more time. Let's not waste the time and go back here. So in this task, you're going to understand the concept of flags and switches, arguments, so on and so forth. So basically, let me explain from here why this is being run. So take a look at this. So this is the command we talked about that can be used to display the contents of a specific directory. Okay. Now, sometimes you see me running -a, -ls, -ls-la, so on and so forth. So these are called arguments. They are used to supplement the functionality of the command or to serve a specific purpose. You can take a look at all of these arguments in the man page of the command or in the help menu. For example, as you can see, ls-help. So this is called the switch, the help switch, and this will display, guys, the usage of this command ls, and these are the specific arguments. As you can see, it's declaring that these are arguments. So arguments, most of the time, or all the time, always, they are prefixed with single dash. A single dash or a single hyphen means that this is an argument. Okay, now this means a switch. So whether you use -a or --, all it serves the same purpose. Personally, I am more comfortable using the arguments because I cannot all the time memorize the flags, right? So I always use the arguments. So here, and as you can see, the arguments that we can use with the ls command. Now, if you use the man page, you can get complete overview and complete know-how on the command itself. Make man your friend. I mean, man is your friend if you want to learn about specific command. The help menu is your friend when you know the concept of the command, but you want to get familiar with the arguments. Okay. Now here, if you want to learn about the command, you can use the man. It's really a man, right? I mean, no offense to females, but it's a man. I mean, it can teach you everything about any command you want. Okay, let's now try the attack box. Where was this? Okay. Yeah. Yes. The password is TryHackMe. Okay. Now I guess this is clear. File system interaction continued. Okay. How would you create file named new node? So basically here we come to creating files. PWD, we are under TryHackMe. Now we learned that files can be created in more than one way. For example, if we say echo TryHackMe send to file 1, right, and then ls cat file 1. As you can see, I have a file now created named file 1. So files can be created in more than one way. Echo being one of them. Another way is to use touch file. So what's required here? How would you create a new file, new node? Touch new node. But text, does it specify an extension? No. So now ls, we have a new file named new node. If you want to get information about specific file, the nature of the file, you can use the file command. As you can see, it's empty file. If we use the same command on the file we created using echo, as you can see, it's ASCII text because the contents stored within this file is a mere string. On the deployable machine, what's the file type of unknown one in TryHackMe's home directory? ls file unknown, and as you can see, the type of the file is ASCII text. It's really not an unknown file. They should give it known because you know it's easy to find the information about this file. I mean, if it was encrypted, I would name it unknown. Anyway, how would we this time? How would we move the file, my file, to the directory my folder? Here we talk about moving files. Okay. So we have these directories, these files, and this directory. If I want to move a specific file into that directory, what I have to use is to use the mv command. Mv command moves a file from one location into another. It can also be used to rename files. Put this in mind. So mv, what's required to move here? How would we move the my file? So my file, the source is my file, and the destination is my folder. As you can see now, ls my folder. Now my folder directory has my file. Now if you check the current content, as you can see, my file doesn't exist anymore here because it has been moved to my folder. Let's talk about the case where we want to rename a specific file. So cd to my folder, and now we have my file, mv my file, the source, and in this time I'm not gonna move the file anywhere. I'm just gonna rename it. So my file, the source, in the case of renaming a file, it denotes the old name of the file, and then new file. ls, as you can see, it has changed to new file. What are the contents of this file? Cat new file. This is it. Okay. Permissions. Okay, permissions is a vast topic, guys. It's a really vast topic. And if you don't master permissions, you haven't mastered anything in Linux, because it's the most important subject, I think. I mean, personally, I think it's the most important subject, especially if you want to use Linux, or if you want to use your knowledge in Linux in the pen testing or in the cybersecurity arena. You need to understand permissions. I'm gonna explain it to you in a very brief way. Okay, on the deployable machine, who is the owner of important? Let's clear ls. So we have a file named important indeed. We're going to check out the owner of the file, the owner of the permissions. How do we do that? We use ls-la. Here we reveal the hidden contents. I didn't mention this before. And also we reveal the permissions and the owners of a specific file, all the files. So the file important, as you can see here, let's talk about the permissions. Here, the column here displays the permissions on this file. Read, write, and execute. We're going to talk about what every single one of them means. So R for read, W for write, and later you will see X, which stands for execute. Now, the file named important, its owner, as you can see, is user2. So that's the user that owns the file. We also see user2. So is it the same user mentioned 2 times? No, of course not. It's not that stupid. It is the group. Now, this is the group that owns the file. So usually when a user owns a file, they have complete authority over the file. They can read, they can modify, they can delete the file, unless specified otherwise. Now let's talk about the permissions. Now the first 3 slots here are for the user or the owner. So meaning read, write, but there is no execute. What does that mean? It means that the owner of this file, in that case it is user2, can only read and write. They can display the contents and they can change it, but they cannot execute. So if this was a file or a binary that can be executed and there was no execute permissions, even though user2 is the owner, they cannot execute the file, the binary. Now the other slots, three slots here, they are for the group. So who is the group here? It is the user2. What the group user2 can do, I mean, what are the members of that group able to do? They are able to only read. So whoever is part of the user2 group, they can only read the file. Okay. Now you can display the groups and their members using cat etc group. You can see here the groups. These are the groups, and we can easily see user2 being a group here. Okay. Clear ls-la. Back. Now the last 3 slots are for everyone. Everyone except the owner and the group. What they can do, they can only read. For example, let's take an example. Cat etc pass wd. Take a look at the users here. So we have user2, we have TryHackMe. So when I say everyone here, it means everyone other than user2 and whoever is part of user2 group. So everyone can only read. So if we have a third user, such as whatever user1, so user1 can only read because user1 is not user2 clearly, and if I don't add user1 to the group user2, they cannot be assigned these permissions. So it's safe to conclude that user1 or everyone applies to user1 in that case. So everyone other than user2 or members of the group user2. Permissions in a nutshell. Now sometimes permissions can be used or can be assigned. I mean, you can use permissions using the numbers. So you have here the letters, read, write, execute, and sometimes we denote permissions using numbers. So I'm going to point you to a resource where you can see every letter here, what's the corresponding number to it. And why numbers are important in permissions? Because sometimes we use numbers to assign permissions instead of letters. Now we assign permissions or remove permissions using the command chmod. If you want to change the owner of the file, you can use chown. Now I have covered these in the first volume of Linux fundamentals. I'm going to put the video link in the description so you can get back to it. What would the command be to switch to the user to? Now here we switch between users. So basically, if I am TryHackMe, I guess ID. So it's TryHackMe. If I want to switch into another user, I would use the command su-l. Su-l will allow me to log in to that user and have the same shell as if I have logged in separately with that user. But here it's mentioned as su-user2. So if I say su-l user2, the password is user2, and now I'm logged in as user2. Output the contents of important. So ls. Okay, so here we are under user2. If we go back and navigate to Ubuntu, maybe not here, it's under TryHackMe. Cat, the file name is important. That's the contents of the file. Common directories. Now common directories are a couple directories that you need to get yourself familiar with if you want to understand Linux file system. For example, here we don't need to get back here to the terminal. So for example, var log. So here it is for the logs. So all the logs, the web server logs, system logs, access logs, all sorts of logs that the system and other tools create are stored under this directory. /temp, it is a temporary directory used by the system, as you can see, to store files that are not accessed that frequent. For example, temp can also be used if you got a shell on a system and your shell is not privileged. I mean, the user you got access to is not privileged and you want to create some files, you can use the temp directory. Normally it's a low privileged directory. Name the home directory of the root user is /root. Now there is another one is /etc, which contains the configurations of the system and other tools, including the passwords, the shadow file. It also includes the configurations of the web server, other servers, other tools, so on and so forth. Conclusion and summary, and now we jump to the last one. So terminate this, and now we go to Linux Fundamentals Part 3. Keep this running. Okay, that's the finale. Deploy the machine. Now we're gonna log in. Now we're gonna start the machine. This time we're gonna use SSH to log into a completely different machine. Alright. Next up, terminal text editors. So here we talk about Nano and Veeam. So Veeam is kindly more difficult to deal with than Nano, but if you get used to Veeam, it's really amazing. But for beginners, we're going to talk only about Nano here. So create a file using Nano. So as you can see, guys, there is more than one way to create a file. The echo, the touch, the cat, and now here we use a text editor called Nano. So okay, edit task 3 located in TryHackMe's home directory using Nano. What's the flag? So basically, I don't know what to say here, but it's not the questions are not kind of sufficient to make you understand the tool Nano, because you can simply use cat to display the contents of the file. So we're gonna teach you how to use Nano in a while when this comes. Okay, so SSH TryHackMe at yes TryHackMe. Okay, clear ls. So we have a file named task3. We can edit this file using the text editor named Nano. Alright, Nano is very simple to use. Let me tell you why. Because as you can see here, all the controls are mentioned down here. And you might be asking, what is this row? The row here stands for control. So if you want to execute one of these commands, you're going to use the control coupled with the corresponding letter. Let's take an example better than this one. So cd var log. So we have the logs here. Let's cd to the access logs. And now we nano access log permission denied. Wow, okay. The other one. Okay. Now let's say you want to search for a specific string. So you don't want to use grep, right? I don't like grep, for example, but I want to use nano, and I want to do that process similar to how we do that in Windows. Simply we use Control W to search for a specific string. Now here, as you can see, we can use this one. How do we get out of this jail? For example, I open the text editor, the terminal is gone. How do I get back to the terminal? I use Control X. So pressing Control with X simultaneously will exit the terminal. Going back. Now, if you want to paste some text, use Control U. Let's exit the terminal now and copy some text. Copy error log. So you copied this, and now access the Nano, and now you want to paste it. So as you can see, it's written Control U. Cut buffer is empty. Paste. It's not empty, man. Sometimes, because I'm opening from opening the terminal in a browser, you may see some inconsistencies. But if you're opening the terminal on a separate, standalone machine, like not from a browser, this is a machine opened from a browser. So some controls may get affected with the actual controls of my Windows machine. Now, what if you want to? So, as you can see here, after you have made changes, it can ask you to save or not. So simply you press Y and you save. But it's gonna exit. What if you want to save and stay in the text editor? Let's go back and make some changes, like saved. Okay, and now what you can do here, guys, you can use another switch or another control. So Control Z. So, to save without exiting, it is already mentioned, Writeup. So Control O. Okay, I'm not saying OH, I'm saying O. Control O. As you can see here, it's asking you for the file name to write, and I want to save the changes inside the same file. So I'm gonna press Enter, and now the changes have been saved. Okay, now I removed the saved. I'm gonna save the changes one more time because I don't want to put the word in the access log. So yes, and now exit. General useful utilities. Alright, so here the example is downloading files and hosting files. So you know that, guys, from the previous videos. Most of the time when we compromise a machine, we need to download some scripts or some tools from the Docker machine, right? So to download files, we use wget. Very simple. Wget with the URL. That's it. I think you know it. And here we talk about how to serve files so they can be downloaded. So basically, we're gonna open a new terminal or new tab. Zoom in. Zoom, 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 zoom. So here, go back to the home directory, cd TryHackMe, clear, ls. We have task 3. So we're required to serve, as you can see, the file .flag.txt. It is a hidden file, as you can see, because it's prefixed or preceded with dot, which makes it a hidden file. Alright, so we want to download the flag file, but from the attacker box. This is the attacker box. This is the machine we're working on. I want to serve this file so I can download it. So what do? I use a quick way to spawn a web server. I don't need to download XAMPP and bother with Apache, MySQL. No. You don't need to do that. You can use Python 3-m http.server, and now you're hosting the web server on the machine. As you can see, this is the URL. So basically, and don't forget to mention the port. So say I want to download this file. I go back here to the attacker box and I use wget and the URL. Of course, we're not gonna use zeros as the URL. We're gonna use the IP address of the server. So it is the machine IP address, and then the port 8000, and then the path to the file. The file is here, .flag.txt. You're gonna use the dot with the flag, otherwise you will get 404. As you can see, the file has been downloaded. ls-la and cat flag. This is the flag. So that's how you download files and serve files on a web server. Use Control-C to stop the Python web server. Anyway, processes. Okay, I know it seems scary, all of these screenshots and readings. We're gonna simplify all of this. ls. Okay, so here we're gonna control. Okay, let's talk about the backgrounding and foregrounding. So I talked about this earlier in the video. So say I want, as you can see, this is a great example of using the backgrounding and foregrounding. So this process now is running in the foreground, meaning that the output of the command, as you can see, we can see it clearly on the terminal screen. What if I want to get back to the terminal while keeping the tool running? I can use Control-Z. Now it says it stopped. Hasn't actually stopped. It just was sent to the background. You can make sure that the process is still running by using PS AUX. As you can see, the web server is still running in the background, right? What if I want to bring it back to the foreground, meaning I want to interact with the process again? I can use FG. As you can see, it brought up the tool along with the output. So I go back here and download the tool one more time, download the flag one more time. Look at this. We are getting the output back again. So now let's stop this using Control-C. Okay, and let's talk about the processes. So processes can be seen using PS command. You can see the running processes, but this is not sufficient, and most of the time you're not going to use it. So you're going to use PS AUX to see all the running processes, their PIDs, the path to the process, the user running the process, and other details. Look at this output. It's very scary output. So as you can see, every details that there is about the process is mentioned here. Alright, so you can see a description of these columns up there. You can see the user running the tool, the PID, the consumption of the resources, CPU, the memory, the size, the shell, and the start time when it has started, the elapsed time, and the command. That's the command used to run the process. That's why when you are doing incident response, or even if you want to escalate the privileges on a machine, it is inevitable that you will go through this output. You want to see the running processes. In case you are doing privilege escalation, you want to see what are the processes running as root. So processes running as root are a prime target for attackers, because if that process has an exploit or has a vulnerability or a misconfiguration, then the attacker can harness this opportunity and escalate as root using the process. In case you're doing incident response, you want to see if there is a malicious process, unfamiliar, unrecognized process running. That's where the importance of PS and AUX comes into light. So let's see here. What are the questions? If we were to launch a process where the previous ID was 300, what would the ID of this new process be? So basically, the PID of the process is here, and it's incremented by 1 if there was no other process occupying the PID. That's why it's 301. If you wanted to cleanly kill a process, what signal would we use? So basically, here it comes to killing processes. So normally, I guess you know that if you want to kill a process, you can use the kill command with the PID of the process. Say I want to kill this process. I'm not going to kill it, but say if I want to kill that process, I use the kill and 1084. This will kill the process. Now this will kill the process abruptly without any cleanup. Here you can use the signal term to kill the process, but allow the process to do some cleanup, so nothing crashes while the process is exiting. It's like, instead of closing this browser using the shutdown, so sometimes if you are literate in computer, some people would just shut down the computer to get rid of all of this, right? So instead of that, you just clean up, right? You can close it from here. Same here, you can use signal term to clean up before you exit or kill a process. Locate the process that's running on the deployed instance. What flag is given? So there is a process running here with a flag. I know it's here. Look, this is where it is. But how about if you come to a scenario where there are a lot of processes and you want to extract a certain process with a certain pattern? So you can again use grep. So PS, AUX, grep. Okay, let's use something different than this THM. Let's say I want to grep the SSH process. So I use SSHD or only SSH. As you can see, I see a list of the running processes for the SSH server. So grep with PS are very common and frequent. What command would we use to stop the service, my service? So we come to using the services. So basically, if we want to start, stop, enable, disable a service, we're going to use the command systemctl. So systemctl, as you can see, is used to start and stop services, and not only that, it's used to enable or disable a service at or in the bootup. So basically, it's similar to the startup in Windows. So basically, in Windows, there is a column here called startup. Windows has made it difficult for people to. I guess I have to. It's not here. Yeah, startup apps. As you can see here, I can see the applications that start in the bootup. Same here. I can use systemctl with the word or with the switch enabled, say Apache 2. This will not start Apache 2. Be careful. This will add Apache 2 to the list of the processes or the services that will start when the system boots up. After the system boots up, it's going to start the service. If you want to remove it from the startup, you're going to use disable. Now it's the same for start and stop. Start and stop is for starting and stopping a service. What command would we use to start the name or the same service on the boot up? We talked about this. What command would we use to bring a previously background process? We talked about this as well. On to the next one, maintaining your system automation. All right, this one is funny task. Let's scroll down. Ensure you are connected. Okay, I'm connected. When will the cron tab on the deployed instance run? The cron tab, as you can see, guys, is a file that maintains or stores all of the scripts or maybe commands that run on a periodic basis, daily, monthly, weekly, every certain hour, every certain minute. We use a cron tab for that. It's very useful for backups as well. The question here is, when will the cron tab on the deployed instance run? It's talking about the cron tab itself. So we can use the running, we can view the scheduled tasks, let me call it, or the scheduled cron jobs using the cron tab -e. Scrolling down, as you can see, there is only one entry here. At reboot, var opt processes.sh. This means that this process or this script will run at reboot every time the system reboots. So we can go to, or we can cat var opt processes. I just don't understand why. Oh, there is none here. Where is that process? There's supposed to be a script file named processes that doesn't exist. ls-la. Okay, cat TryHackMe. Look at this one. For I, it's a for loop. For I in 1 to 5, do echo, here is your flag, thm process hunter. Done. Obviously, this is not the script that was added to the cron job, but it's another one. I don't know. Here there is no question about this flag, but by the way, if you have uncovered the flag, I mean, it's good on you. I didn't expect that there is a flag here because there is no question about this flag. So if you run this TryHackMe thing or script, as you can see, for 5 times it's gonna echo, here's your flag. For 5 times, come on, this is your process hunter flag. This is a for loop, by the way. Or anyway, so when will the cron tab run? It is at reboot. We saw that in cron tab -e. Now, where is this located? So cron tab is located under etc. So cat cron tab. This is the cron tab. Here you can see the syntax. Sometimes cron jobs are stored here. So you might need to run one of these 2 commands, cat etc cron tab or cron tab -e. Completely different contents. Anyway, going back here, as you can see, these are example of how cron jobs are configured. So we have here asterisks, where every asterisk and its position denotes something. For example, the first one, it denotes the minute, and the other one, or the second one, denotes the hour. And here the day of the month, or the month itself of the year, and day of the week. Let's take an example. This one. So when there is asterisks, it means that there is no requirements about the corresponding meaning of this asterisk. So this position here, it is for the hour. So it doesn't matter at which hour it runs. It doesn't matter at which day of the week, or which month of the year, or which day of the month here, day of the week. So when there are no specifications here, we only take a look at this. So 17, it means it runs every 17 minutes on hourly basis. That's why here it says hourly. Other one, we have 25 minutes, 6 hours. So here it runs 6 hours, every 6 hours, 25 minutes daily. It doesn't matter, as you can see, the day of the month, the month of the week, day of the week. It doesn't matter. So it runs on a daily basis. Here it's on hourly. I know this is running every day, of course, but it runs every day and every hour. Here it doesn't run every hour. It runs on a daily basis, but it looks like every 7 hours, 6 hours. This one, 47 minutes, 6 hours, and we have a specification on the day of the week. It runs the day on the 7th day of the week. So this means it runs a weekly basis. It's gonna wait till the end of the week and run. And the last one, as you can see, we have a specification on this position, 1. This position denotes, as you can see, the day of the month. So it runs on the first day of the month. So every first day of every month, it runs. It means it runs on a monthly basis. These are the meanings. If you want to get, if you are new to cron jobs, you can use these 2 websites, online tools, to generate cron jobs. So here specify the minute, the hour, day of the month, month of the week, day of the week, and then it's going to give you the command that you should execute or the entry that you should store in the cron tab. Maintaining your system package management. Here we talk. Here there is no questions because the instance is not connected to the internet, so we cannot update the packages. But anyway, guys, cd apt var. I guess I forgot where it's located. Come on. So enter etc. I don't know why I'm going to these directories. This is a configuration of the system, so I should go to etc apt. So ls, here we can see the sources or the packages from which the system downloads the tools, the software, or the updates. We have 1 sources.list. It's the default 1, and it's not recommended, guys, to add any entry to that list. If you want to create a different or a separate package source, it's recommended you create this under sources.list.t. So go to that directory, and here you can create another source. So whenever you execute update, what's going to happen? The system will update all the existing packages from first this source or this file, and then it's going to check this directory and see if there is any package repository that you have created. That's the brief of this task. But I guess, guys, all of you know how to use apt update, apt install. So basically it's the command apt that's used to manage packages. So you can use apt to update the existing packages and to download or install packages from different sources. Maintaining your system logs. We talked about the logs, guys. They all exist under this directory var log. And let's answer some questions. What is the IP address of the user who visited the site? Now again, we reiterate that all logs of the web server are mentioned or stored, in the access log. So if we go to Apache 2 cat access log, we can see here the entries, and there was one GET request from this IP address to retrieve this file, the IP and the file. So that's what it is, guys. This is it. This was, of course, not everything about Linux. It's just an introduction. I hope, guys, you found this useful, and I encourage you to visit the last volume I published 2 years ago. It was also fundamentals on Linux. So that was it, guys. I hope you enjoyed that, and I will see you in the next video.